Today we'll be looking at what are called nth roots of polynomials. This is section, new chapter, chapter 5. This is section 1, and we're going to cut it up into three parts, but they're all very much related to each other. And they're called nth roots because we know how to take a square root, and maybe some of us cube root and fourth root. Of course, we may have to use our calculators for some of these, but the rules we'll be talking about, they apply to any number up here above the radical symbol, okay? And this radical symbol, the little number there, it has a name, it's called the index. Okay, so our index is normally a 2, and so that's just the square root symbol, but it could be a 3, which would be a cube root. It could be a 4 up here, that's a fourth root, fifth root, and then finally we call it an nth root, meaning we could take whatever n is, and that would be given to you in a problem, or we'd have to try to figure it out based on some given information. So we're just going to be practicing taking various roots of different numbers. Now, an important concept to understand is like what we mean when we say take a root of a number. So let's look at ones we know, for example. Let's say I have the square root of 9, and most of us know the square root of 9 is just 3. Well, if you dissect this just a little bit, we don't put an index on square roots, but it does have an index, and it's an index of 2. And we said when we ask for a square root of a number, what we're asking for is what number is multiplied times itself. Okay, I've got a pair of 3's, so 3 is multiplied by itself, and so the answer is 3. Think of it this way. Square roots are the opposite of squaring something. So right here, I've got the square root of a 3 squared, but the square root and this squaring, they are complete opposites. They undo each other, and so we just end up with 3 for an answer. Let's look at one now that's more complicated. Let's say I've got the cube root of 8. Some of us may know that's equal to 2. But the reason it is because in this case, the index of 3 means what's multiplied times itself instead of twice, like the square root. What is multiplied times itself 3 times? Well, 2 times 2 times 2 is 8. And what's multiplied times itself 3 times? The answer is 2. And again, you could look at it this way. Cubing and cube rooting just undo each other, and so we just end up with 2 for a simplest answer for the cube root of 8. If we're doing fourth roots of a number, like 16, in this case we're looking for 4 of a kind. And so if we factor 16, it actually factors as 2 times 2 times 2 times 2. And therefore it is just 2. 2 is multiplied times itself 4 times to get the 16. And this is all fine and dandy when we've got something that factors into 4 that are exactly the same. In this case, 4 2's. Okay? But not every number does that, obviously. And so the question becomes, well, what do we do when we have to take the fourth root of something like an 8? An 8's not made up of 4 2's multiplied together. It's only 3 of them. We just saw that. Okay? And this is where we're going to have to use a calculator for it. But again, when we use a calculator, we're going to get a number for this thing. It's going to have to be rounded off. But that number will be what you could multiply times itself 4 times to give you an 8. So let's continue on here. Let's look at a few of these things and then compare them to something that's going to be new to us. Look at how these two are set equivalent to each other. And now we can actually take an index of n, so the nth root of x, and we can rewrite it as an x to the 1 over n power. And we'll go into that in more detail. For right now, we're just going to compare them using a calculator. And I'm going to show you quite a few examples of using a calculator to do this. The one I've chosen to use here is Desmos, just because I know most of you have that on your iPads. Okay, depending on the calculator you use, the input method may be a little bit different, but what will be the same is essentially some of the symbols that you use. So in ours, we do have a square root symbol. There's the square root symbol right there. Okay, and this is the nth root symbol there. That allows us to take cube roots, fourth roots, and fifth roots. So let's go ahead and let's do the first one. I'm just going to take the square root of 4. So we just hit the square root. No, we don't. We hit the 4 first, and then we hit, no, we don't. Do it that way. Every calculator is a little different. Just didn't pick up my first thing. So we'll hit the square root button, and we'll type the 4 in there, and you can see over to the right there, it does show us the answer is 2. So we'll put a 2 down for that. Let's do a cube root now. To do a cube root on Desmos, you again hit the nth root button. Hit that first. Oops, let's clear everything out here. There we go. You notice I'm flashing up here, or at least I was flashing up here at this cube spot. Now it's flashing up there, so I'm going to put my 3 up there, my index. I'll just tap down below the radical, and I'll type in the number 8. And you can see over here, it's giving me an answer of 2. And again, that's because it's 2 times 2 times 2. And our last example, let's do the fourth root of 81. Again, we'll use the nth root button. We'll put a 4 in for our index, and tap over 81 underneath the radical, and you can see it's given us a 3. So pretty straightforward. We got a few more examples of these things, but we're also going to look at some particular rules next. That's what I forgot to show you. Sorry. I want to compare all these things now using this x to the 1 over n power, and I'll show you how you can write equivalent statements using fractional exponents. In this case, all you have to do is take what you're taking the root of, in this case 4, and raise it to the 1 over, and then whatever the index is, in this case 2. So we go like that. And you can actually do this on your calculator as well. See if I can clear everything out. Nope. So I'm going to go 4. Maybe. Go 4. There we go. And now I'm going to raise it 2. And notice I hit that A, B button. And I'm going to go 1. We'll see if this works. Divided by 2. There we go. So it's 4 to the half power. And you can see over here we get the same answer. It is equivalent to 2. So 4 to the half is exactly the same as the square root of 4, which equals 2. If I want the cube root of 8, I can write that using a rational exponent as 8 to the 1/3. Again, note the index is the denominator in my exponent. And then I'll grab the graphing calculator, the calculator here. And let's go ahead and do, we'll hit enter, and we'll go 8 to the power. So I hit the A to the B button there. That raises it to the exponent. And I want to the 1/3, so 1 divided by 3. And you can see it also gives me a 2. So it does agree. And then, there we go. The last one, we got 81 to the 1/4 power. And we'll just type that in. And we'll go 81 is to the 1. I hit divided by 4. So that gives me 1/4, and you can see it's giving me 3 for an answer. Okay, so this one was 2 again, and this one also gives you 3. So the reason this is super duper powerful is because this is what we call, all of these are written in what's called radical form, which we have a few rules on how to add and combine those, whereas these over here, these are written in exponent form, but we call it exponential because we're fancy. In exponential form, we can use all of our exponent rules for. And we have a lot more of those than we do radical rules, so we have more options and more ways to work with problems. Ooh, not the rules yet. These are just more practice problems, I guess. So now you've seen, though, this is just more practice, but these don't all come out even, so let's look how we deal with those. I've got the square root of 7. Now remember, you could, if you had a calculator that didn't have the radical symbol, this is the same thing as 7 raised to the half power. Remember, the index is 2 there. So you could enter it either way. Now I'm going to use the square root button because I do have that on my calculator. So I'm going to grab the calculator here. Let's get to our main screen. There we go. And I'll go square root of 7. And note over here what we get. We get this long decimal. Now this is an irrational number. It goes on and on forever, and there's no spot where it just has a repeating pattern that just keeps coming up. So we have to round it. And they'll ask you either to round it to the tenths or the hundredths, 1 decimal place or 2 decimal places. Let's go ahead and go to hundredths here. Okay, remember how we round. So I'm going to write down 3 decimal places to make sure we all round the same way. Okay, so I'm trying to round to the 2nd decimal place, and so I look next door, and if this number here in red, if that's a 5 or higher, then I'm going to round up, and so my answer here would be 2.65. So go ahead and round that up if that number right next to the 2nd decimal spot is 5 or greater. Let's try the cube root of 12 here next. There we go. So I'm going to use the nth root button this time. There it is. I'm going to put the 3 in for my index, and then 12 under the radical. And I know I'm going to get a decimal because 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27, so it's somewhere between 2 and 3, this number is, that if I multiply together 3 times, I get a 12. And you can see over here what they've already given to us, 2.289. Again, I'll write that down, 2.289, and I'm going to the hundredth spot here, so I look next door. See, that's a 9, so that 8 gets rounded up. 2.29 is what this is closest to, and I should put approximations there because those are rounded off. And then lastly, our 5th root problem here. Let's go ahead and do the 5th root of 16, so I'll use the nth root button. I'll put a 5 for my index and 16 under the radical. 16 under the radical, there we go. Looks like it's 1.741. So again, we're rounding off to the hundredth spot, and I look next door at the 1. Well, that's not bigger than 5 or equal to it, so it's just 1.74 is where I leave it at. Not too bad. And that's all you do today, essentially. We are going to look at some rules here and some patterns maybe help us out. We got quite a few of them. But I want you to first note, this is just, we're talking about different indexes, and we're classifying the indexes. Remember, the index is the little number that sits on top of the radical, that n right there. That's your index. We're dealing with n's that are greater than 1. And we've broken them into 2 groups. One of our groups is going to be, what if you have an even? What if you have an even index versus what if your index is odd? Okay, and so some of these rules, if what you're taking the root of, so we're dealing with even indexes, and if underneath the radical you have a negative number, it is no real solutions. Let me pull out some examples of what that looks like. These all are radicals with even indexes. 2 is even, 4 is even, 6 is even. Because we're doing the even root of a negative number, all of these are not real. That means we'd have to use the imaginary number I to try to evaluate them. Okay, and for right now, we're just going to go with not real. So that's our first statement. You can't take even roots of negative numbers. That's all that says. Now it says, okay, what if the a value, what you're taking the radical of, is equal to 0? Then it doesn't matter. You're just going to get a 0. So let's look at some of those. Again, it does not matter whether you're taking the square root of it, the fourth root, the nth root where n is even. All of these, you get the same answer. They all equal 0. And then our last one, if we're dealing with evens, if you take the nth root and your n is even, and your a value, what's under it, is a nice positive number, a is bigger than 0, then you do get two solutions, this plus or minus. And we've dealt with these plus or minuses before. Let's pull him in. And there's a little bit of confusion here, so I'll try and make it clear to ourselves. So when we take the square root of 4, it technically is both positive 2 and negative 2. And the reason is because 4 could be written as a 2 times 2, or it could be written as a negative 2 times negative 2. So if it's an even index and a positive number that you're taking the root of, you do always get this plus or minus answer. Now, in this case, when you do have a choice like this, plus and minus, in general, we only give the positive one unless we're solving an actual equation. The positive one is called the principal root. And that only happens when you have a choice. If it's a plus or minus answer, in general, we just give the positive one. Now, that is different than solving an equation. If I have an equation like x squared equals 4, and I square root it, because it was an equation, I actually have to give both answers. Because the original problem said what squared gives you a 4. And the answer is 2 squared or negative 2 squared. In general, if they just give you an expression, no equal sign, if you have plus or minus for a choice, you just give the positive one. But for right now, let's go ahead and answer each of these things, giving both of them. So square root of 4 is 2. Fourth root of 8, we'd have to get out our calculator for that one. So let's grab our calculator. Let's do the fourth root of 8 on it. And so I'll hit my nth root button, and I want the fourth root of 8. You'll see I get 1.68. Hopefully you see that. 1.681. So we're going to round that. So the fourth root of 8, it's terrible looking fourth root. The fourth root of 8 is equal to 1.68 approximately, and we can put plus or minus even next to that. Let's write that a little neater. Now again, if it's not an equation, we'll just probably give the positive one. And for your assignment today, it would be fine for you to give just the positive one when you have a choice. Last one, we got the 6th root of 64. Let's see what that is on our calculator. All right. See if my calculator will catch up here with me. There we go. 6th root. So nth root, I put a 6 in for my index, and 64. And it is exactly 2. So the 6th root of 64 is equal to plus or minus 2. Okay, so use your calculator for these. That was all of our even ones. So the even ones, we've got 3 things we have to look at. If the a value is less than 0, we get no real roots. If it's equal to 0, we get 0. And if it's bigger than 0, we get plus or minus whatever the square root, 4th root, 6th root is. Now let's take a look. Let's get rid of some of these things, maybe. Let's take a look at what happens if we deal with odd indexes. Let's pull out the first type of example here. Here we go. And it just says, now if you're taking odd roots, notice these are cubic. This is another cubic. This is the 5th. It could be 7th. It could be 9. And this time you've got a negative underneath the radical, so a is less than 0. It means you can do it. We can actually type these things into our calculator, or we can just figure them out. So, for example, the cube root of -1, since I can write -1 as -1 times -1 times -1, what's multiplied together 3 times? -1. Cube root of -8, it can be written as -2 times -2 times -2, so it can be done. It's just equal to -2. 12, I can't write it as 2 times 2 times 2, because that doesn't equal 12. I can't do 3 times 3 times 3, but it does say up here that that is possible. You can take an odd root, 5th root in this case, of a negative number. So let's grab Desmos and see what it has to say. So we'll do the 5th root of -12. This will go faster if my calculator responded a little bit quicker, but there we are. 5th root and -12. There we go. And you can see it gives me, if I can zoom in there for you, -1.643, so we'll round it to -1.64. Notice we don't get plus or minuses when we're doing odd roots. Let's move this out of the way here. Next type. This has to do with 0 again. Now we're taking odd roots of 0. Okay, and again, it's just equal to 0. So evens or odd roots of 0 always gives you 0. So that's not anything new for us. And then lastly, if we're doing nth roots, our index is odd, and the a value is positive, we again only just get one answer. The only time we get this plus or minus is if we're taking even roots. And so I got a few examples like these. But these really are no different than what we have been doing. So you take the cube root of 8 on your calculator, or we'll just know it's equal to 2. We can take the 5th root of 243. Maybe we know what that is, but let's find out. Grab our calculator here. 5th root, here we go, of 243. Looks like it's about 1.87, so it didn't come out even. So approximately 1.87. Then the, oh shoot. I was going to say something didn't seem right there. Let's try that again. If you notice over here, I had fifth root of 23, not 243. So let's see if we can correct that. Oops. There we go. That's better. I thought this came out even. It comes out to an even 3. And lastly, the fifth root of 8. I'm just going to go in there and see if I can edit inside here. Now let's put an 8 in there. Fifth root of 8 looks like it is 1.5 approximately. Terrible approximation symbols. It is approximately equal to 1.52. And we're done. Okay, so if I was doing this at home, what I'd do is I'd grab the worksheet that you'll get for tonight. I'd write down the original problems and have my calculator handy and just you'd type them in and get your answers for them. These were just some more examples, and we aren't going to go through these things right now. It is important to note, I think, hey, can I take the cube root? Can I take an odd root of a positive number? Yeah, we can take odd roots of any number we want to. Can I take the fifth root of a negative number? Yes. Okay. And here we've got fractional exponents. And so we now know how to use our calculators for that. You just raise 9 to the half power, or negative half power, and let your calculator do the work. Now, this does mean, though, that 2, remember, is our index. And so this is the same problem. This 81, the 4 is our index. That's the same problem. And this would be the cube root of 64 raised to the negative 2 power. And I guess this would be more common to put them in parentheses, although in certain ways you can do it either way. You don't have to know that for right now. What you want to practice, though, is being able to type this into your calculator and getting the correct answer. If you can figure out the pretty fraction answer, because this one does come out to a nice pretty fraction answer, do that. Okay, that may require you to press a few more buttons on your calculator. Give these a shot. We'll cover questions tomorrow.